So in this video, we are looking at a couple of miscellaneous problems from nonlinear relationships. Now, I've pulled out two questions which are past HSC questions. So that's like the big final exam here in New South Wales, in Australia. And our miscellaneous problems are going to have to do with one quadratic relations one, which we can see here, and we're going to have one on reciprocal functions. Now, this question says, on another planet, a ball is launched vertically into the air from the ground, and the height above the ground, h meters, can be modeled using this function here, where t is measured in seconds. Now, the graph is shown below, and it's saying, based on the graph, what is the maximum height reached by the ball? So we just want to find, because this parabola is the coefficient of your t squared is negative, it's going to have a maximum value or a maximum turning point. Now we can see that this occurs about here. And we can see that this is, if you line it up here, it lines up with 24 meters. So here, the maximum height reached by the ball is 24 meters. Next one is saying, based on the graph, at what 2 times is the ball at 3/4 of its maximum height? So for part B, the max height is 24, so we want to find 3/4 of the max. And that gives us 18 meters. And we just want to look from the graph, where can we see it being 18 meters? So let me just zoom in here. We can see 18 meters is here. 15, 16, 17, 18. That's here. So that will be here. And that will be here as well. And we just need to draw down. So here we can see that this happens at 1 second and 3 seconds. Okay. So from the graph, we can read that this happens at 18 meters when t equals 1 and 3 seconds. Okay, next one. We can see we have to graph in this example. So this is telling us that a student believes that the time taken for an ice cube to melt in minutes varies inversely. So anytime you see varies inversely, similar to that last video we're talking about, it means it's going to be some kind of reciprocal relationship. As one gets bigger, the other gets smaller. So varies inversely with room temperature. Now it's saying a student observes that at room temperature of 15 degrees Celsius, it takes 12 minutes for an ice cube to melt. So we want to find the equation relating m and t. So part A here, we know that it varies inversely. So m is going to vary inversely. Remember, we drew this symbol in the previous video with this. So anytime it varies inversely, we can set up an equation, m equals to k over t, where this k is a constant that we can find using these two bits of information. So we can say that when m is 12, our t is 15. So we can say 12 equals to k over 15. And we just want to multiply both sides by 15. So k is going to equal 12 times 15, which equals to 180. So therefore, we can say m equals 180 over t. This is our equation relating m and t. Now what we have to do is we want to complete a table of values, giving temperatures and times. And we're given basically temperatures from t equals 5 degrees to t equals 30. We just have to fill in the table of values. So using a calculator, substitute into this rule, this equation we found relating m and t. So I'm just going to give the answers. You can pause the video and try on your own first if you'd like. But for the first one, we're going to get 36. Next one, 12. And then for the last one, 6. So these are our points. We want to plot them and we want to graph the relationship. So when t is 5, so t is on our x-axis here. When t is 5, so over here, we have 36. So that's going to be up here. When t is 15, it's 12. it's going to be here. And when it's 30, it's going to be 6. So we just have to connect the dots. So going here to this one. Let's try that again. And passing through this one. So we have graphed our nonlinear relationship. We've graphed our inverse variation, our reciprocal function for this particular scenario. So these are some of the questions you would expect to get in an exam. They're sort of exam style questions, some miscellaneous problems on nonlinear relationships. That brings us to the end of the video. Thank you so much for watching, and I'll see you next time.